Picture a massive space rock flying through the darkness, large enough to alter life on Earth if it ever slammed into us. That's Apophis, an asteroid named after the ancient Egyptian god of chaos. Astronomers first spotted it in 2004, and early predictions hinted at a worrisome collision date in 2029, which, to add a twist, fell on Friday the 13th. Though experts soon revised their calculations and announced that 2029 would be just a near miss, rumors continue to swirl. Could even a small impact with a stray piece of debris push Apophis onto a collision path? While official statements say the odds are minuscule, some astronomers warn that minuscule still isn't zero. On the one hand, NASA's refined data suggests Apophis will zip by at a safe distance in 2029. On the other, the asteroid has multiple future flybys, 2036, 2068, and perhaps beyond, leaving enough opportunities for gravitational nudges or small collisions to shift its trajectory. In a cosmic sense, a fraction of a meter per second can be the difference between a harmless pass and a catastrophic event. That reality alone has motivated astronomers worldwide to keep tabs on Apophis, working tirelessly on simulations that either confirm its harmless status or expose hidden dangers. At the same time, this asteroid promises an unprecedented scientific opportunity. Because of its size and proximity, Apophis could reveal details about near-Earth objects on a scale we rarely get to study. From exploring its composition to observing how Earth's gravitational pull affects its rotation, researchers hope to unlock valuable information that could help defend our planet against more serious threats. So is Apophis a harbinger of doom or a treasure trove of knowledge? Or perhaps a bit of both? When Apophis was first discovered in 2004, it immediately stood out. At around 350 meters wide, it was large enough to do serious damage should it collide with Earth. Early orbit calculations hinted at a 2.7% chance of an impact in April 2029. That figure might sound small, but in astrophysical terms it was alarmingly high. Adding to the drama, the predicted date fell on Friday the 13th, feeding all sorts of superstitions. Media outlets labeled it a killer asteroid, while scientists scrambled to refine the data. The name Apophis itself, echoing chaos and destruction, didn't exactly calm public fears. NASA's calculations placed the asteroid passing dangerously close to Earth, within about 31,000 kilometers, closer than many geostationary satellites. If Apophis hit, it wouldn't wipe out humanity like the asteroid linked to the dinosaurs' extinction, but the local impact would be devastating. A direct collision could flatten entire regions, trigger megatsunamis if it landed in the ocean, and cause widespread chaos well beyond the initial blast zone. Fortunately, after a flurry of observations, astronomers quickly revised the odds. They gathered more data, refined calculations, and concluded that an impact in 2029 was exceedingly unlikely. Still, the tension lingered. Apophis would pass near Earth again in 2036 and 2068, setting the stage for years of orbit tracking and fresh updates. Each new observation typically pushed the chance of a collision further towards zero. Yet the story never truly faded. Even as NASA insisted Apophis posed no immediate danger, some scientists remained cautious, especially when factoring in smaller, unpredictable cosmic events. Apophis began to look safer for 2029. But what if something tiny and unexpected changed its path? Enter the small nudge theory. The idea that a collision with a mere 60-centimeter object could shift Apophis's orbit enough to threaten Earth. It sounds improbable, but in the vacuum of space, momentum transfers can have outsized effects. An impact imparting just a fraction of a meter per second to Apophis's speed might set it on a completely different course. Space is anything but empty. Though we picture vast distances, plenty of dust and debris float between planets, left over from billions of years of cosmic processes. Occasionally, these fragments collide with each other or with satellites and spacecraft. Most of the time, such collisions go unnoticed. But if Apophis encountered even a small chunk at high velocity, the transfer of energy could be significant. A swift jolt could shift its path by tens or hundreds of kilometers over time, enough to change a near miss into a direct hit on a subsequent orbit. Adding to the uncertainty is the Yarkovsky effect, where the asteroid's own thermal emissions slowly alter its trajectory. Apophis absorbs sunlight, then radiates heat, which provides a slight but continual push. Taken alone, this gentle force might not be enough to aim it at Earth. Combined with a random bump from space debris, however, who's to say? Given the asteroid's size and speed, scientists pay close attention to the sum of all minute factors. Even if the probability of a dangerous collision remains low, the mere possibility keeps researchers vigilant. Paul Wiegert of the University of Western Ontario decided to quantify the small nudge idea by running an extensive simulation. Because Apophis has been out of our telescopic range since around 2021, direct observations are impossible until 2027. That forced Wiegert to rely on existing data, constructing a model of Apophis's orbit and introducing hypothetical impacts with various sizes of cosmic debris. He discovered that a rock no bigger than 60 centimeters could indeed alter Apophis's trajectory enough to send it through a gravitational keyhole. Keyholes are narrow regions of space where Earth's gravity would deflect an asteroid just right, eventually guiding it to collide on a future pass. The key detail is timing and angle. The collision must happen in a specific segment of Apophis's orbit at just the right velocity to change the asteroid's speed by a small fraction. Crucially, Wiegert's model concluded that while possible, this scenario is extremely unlikely, about 1 in a million for 2036 and 1 in 100 million for 2029. Those odds are minuscule, though not zero, which stokes a certain level of both scientific curiosity and public concern. After all, improbable events do happen. Still, astronomers emphasize how fleeting these collision windows are. The alignment of Apophis, a small chunk of debris, and the perfect collision angle is so precise that it verges on miraculous. Nonetheless, a 1 in a million chance can't be dismissed entirely, and that's why the world's space agencies remain watchful. From 2021 to 2027, Apophis resides too close to the sun's glare, making it invisible to ground-based telescopes. That invisibility window leaves us with older data to rely upon. Astronomers anticipate little change in the asteroid's course, but they can't confirm until it reappears. As a result, for several years, we're essentially operating on best-guess scenarios. In theory, if a minor collision or sudden shift did happen during this downtime, we might not know until Apophis swings back into view. While astronomers routinely track thousands of near-Earth objects, none capture public attention quite like this one. That's due partly to its size and partly to its proximity. Even though NASA and other agencies reassure us that the odds remain tiny, the gap in observation feels unsettling. We like to believe we have eyes on every corner of the solar system, yet the sun's brightness can still hide large objects from our immediate view. There's also the issue of rumor and speculation. Whenever we can't see something directly, theories start swirling. Some claim that hidden data might reveal a bigger threat. Astronomers, however, point out that if something truly dire were brewing, the orbital changes would be big enough to model without continuous observation. In any case, the plan is to renew tracking efforts as soon as Apophis reemerges. Only then can we verify that it's still following the predicted path, or confirm if there's been any unexpected twist. In 2022, NASA's DART mission proved that humanity can deflect an asteroid's path by smashing a spacecraft into it. This groundbreaking test targeted a small asteroid called Dimorphos and successfully altered its orbit. The achievement had immediate relevance for objects like Apophis. If a future measurement suggested Apophis might cross Earth's path, we wouldn't be totally helpless. A DART 2.0 mission could potentially be rushed into development. But planetary defense isn't simple. We need enough lead time to build, launch, and guide a spacecraft to the asteroid, plus time for the slight velocity change to alter Apophis's course enough. The physics behind redirecting an asteroid depends on its mass, rotation, composition, and trajectory. Hitting it in the wrong spot, or fracturing it into multiple segments could complicate matters. Even so, the DART success showed that practical defenses aren't just science fiction. They're now part of our toolkit, though they require global collaboration. After all, if Apophis or any other asteroid seriously threatened Earth, nations would need to cooperate. Space missions are expensive and time-consuming. Data sharing, joint funding, and coordinated strategies would be crucial to avoid duplication of effort. While the DART mission was led by NASA, the European Space Agency's Hera spacecraft will gather follow-up data from Dimorphos. This synergy is a glimpse of how planetary defense might function at full scale, multiple agencies combining their expertise to safeguard the planet. Beyond the doomsday scenarios, Apophis offers a once-in-a-century chance to study a large asteroid as it whips past Earth. Most asteroids that come near us are smaller, and the bigger ones tend to keep much more distance. Apophis's close pass in 2029 will let scientists measure the effects of Earth's gravitational field on the asteroid in real time. We may witness dust avalanches on its surface or slight shifts in its rotational speed, data that could reshape our understanding of how these bodies behave. Asteroids act like cosmic time capsules, preserving traces of the solar system's early days. Some are metal-rich, others contain water or carbon-based compounds. By taking detailed measurements of Apophis's composition, orbit, and internal structure, astronomers can refine models of planetary formation. We might learn more about how life-sparking ingredients were delivered to Earth billions of years ago. There's also the possibility of analyzing Apophis's specific geology. Does it have large boulders on its surface? Or is it a rubble pile barely held together by gravity? Answers to these questions matter for deflection strategies. A single solid rock might behave differently when struck by a spacecraft than a loosely bound collection of gravel. If we discover that Apophis is a certain type of asteroid, that knowledge will be crucial the next time we face an actual threat. Several missions are being planned to capitalize on Apophis's 2029 approach. The European Space Agency is considering Ramses, leveraging technology from its Hera mission, which will visit the Dimorphos system. By reusing components already developed, ESA aims to save costs and reduce risk. Another plan, called SATIS, proposes sending CubeSats to Apophis to observe its approach. These miniature spacecraft can be deployed more quickly and cheaply than traditional satellites, offering a near real-time look at the asteroid's behavior. NASA, for its part, is repurposing the OSIRIS-RX spacecraft into OSIRIS-APEX. After collecting and delivering samples from asteroid Bennu, OSIRIS-RX will head for Apophis, but won't arrive until some months after its close approach to Earth. Even so, extended observations could reveal any surface changes Apophis undergoes due to tidal forces. Tracking how the asteroid's spin, dust distribution, and overall shape shift could unlock vital clues about how asteroids respond to planetary flybys. Each mission aims to gather more than just curiosity-driven data. In studying Apophis, we sharpen our ability to detect subtle shifts in an asteroid's trajectory and respond if needed. We also refine engineering techniques for close proximity operations near a potentially hazardous object. More accurate knowledge of Apophis will bolster our readiness for the next time an asteroid shows up with questionable intentions. Historically, asteroids have shaped Earth's evolution. Just ask the dinosaurs. Today, we stand at a turning point. We have telescopes, radar systems, and orbit modeling software advanced enough to detect threats well in advance. Yet Apophis highlights a nagging reality. Very low risk never fully equates to no risk. Whether it's a random collision with a tiny rock or unexpected gravitational quirks, the door to uncertainty stays open. That's why many experts champion increased funding for sky surveys. Telescopes like the Verisi Rubin Observatory in Chile will scour the sky for near-Earth objects, identifying potential hazards years before they pose a problem. Meanwhile, space-based detection systems could spot objects hidden in solar glare. The earlier we know something's on a collision path, the more feasible it is to send a deflection mission. Cooperation forms another crucial piece of the puzzle. Any effort to reroute or destroy a dangerous asteroid would demand global consensus. Who foots the bill? Which agency oversees the mission? If Apophis turned out to be a real threat, we'd need swift coordination among multiple countries and agencies. That collaboration might be one of the biggest lessons from this asteroid story. Space is a shared environment, and defending Earth is a shared responsibility. Apophis burst into public consciousness with an unsettling message. Even a relatively modest asteroid can spark global panic if early data suggests a collision. Over time, fresh observations ease those fears, but never erase them. Astronomers assure us that Apophis probably won't strike in 2029, or even in later passes, yet emphasize that tiny probabilities remain. Those slim odds keep the asteroid firmly in their crosshairs. Ultimately, Apophis has become a beacon for two contrasting reasons. First, it reminds us of our planet's vulnerability and how easily a sudden cosmic twist could impact life on Earth. Second, it symbolizes the promise of scientific progress. Through advanced telescopes, carefully orchestrated spacecraft missions, and international collaboration, humanity is better prepared to face cosmic hazards than ever before. In many ways, Apophis has given us the impetus to refine our tools, rally global cooperation, and develop real-world strategies for planetary defense. So will Apophis remain just an interesting near miss? Or is there a remote chance it could write a far darker chapter in Earth's history? The consensus says we can breathe easy for now, but keep watching the skies. Only time, data, and continued scientific diligence will confirm Apophis's ultimate legacy. In the meantime, this visitor from the void spurs our curiosity as much as our caution, urging us to learn what we can and be ready for whatever the cosmos may send our way. Thanks for tuning in. Please like and subscribe if you enjoyed the video, and I'll see you on the next one.